So following on from the previous video where we learnt what y is equal to 2 to the x looks like, we're now going to investigate what y is equal to 3 to the x looks like, or y is equal to 1.5 to the x, and then lastly y is equal to 0.5 to the x. What do these look like in comparison to y is equal to 2 to the x? Okay, so let's first draw y is equal to 2 to the x. Now, y is equal to 2 to the x looks like this. This curve that goes through 1 on the y-axis and is increasing faster and faster and faster to the right of the y-axis and is decreasing faster and faster and faster to the left of the y-axis. And it never crosses the x-axis. So this is what y is equal to 2 to the x looks like. And we're going to compare this with these three. Okay, so I'm going to make 3 diagrams comparing y is equal to 2 to the x to each. Okay, so first of all, let's look at y is equal to 3 to the x. Now, y is equal to 3 to the x, if you think about building up a set of values, much like we did with y is equal to 2 to the x, then I don't really need to do too many. If we just look at minus 2, minus 1, 0, 1, and 2, then we have 3 to the power of minus 2, so that's 1/9. 3 to the power of minus 1 is 1/3. 3 to the power of 0 is 1. 3 to the power of 1 is 1, and 3 to the power of 2 is 9. So if you compared that with the previous table in the previous video, then you should be able to see that actually this curve also goes through 0, 1. Okay. And as x increases, so 1, 2, 3, 4, y is increasing 3, 9, 27, 81, and is actually increasing faster than 2 to the x. And so because it's increasing faster, the curve will be steeper. And also to the left of the y-axis, we're getting 1/3, 1/9, 1/27, 1/81, or 1/81st, I guess. And so it is decreasing faster than 2 to the x as well. And so the curve will be below the black line to the left of the y-axis. And so this is y is equal to 3 to the x as compared with y is equal to 2 to the x. So let's have a think about y is equal to 1.5 to the x. Well, 1.5 isn't larger than 2, it's smaller. And so as x increases, 1.5 to the x will also increase, but it will be increasing at a slower rate than 2 to the x. So 2 to the right of the y-axis, it will be increasing slower than 2 to the x. But when x is 0, once again, we're going to get 1. 1.5 to the power of 0 will be 1. And so the curve to the right of the y-axis will look something like that. Now to the left of the y-axis, you're going to get 1.5 to the minus 1, 1.5 to the minus 2, 1.5 to the minus 3, and this will be decreasing and getting closer and closer to 0, but not quite as quickly as 2 to the x. And so we will have the curve will be above y is equal to 2 to the x to the left of the y-axis. And so the curve would look like that. Now, as this number that we have to the power of x decreases and gets closer and closer and closer and closer to 1, when it actually reaches 1, you have 1 to the power of x. And y is equal to 1 to the x would just be a horizontal line. It's y is equal to 1. Okay? So, once you're past that point, once you get past 1 and you're decreasing and you get to 0.5, the curve will actually look a little different. Because now as x increases, you have half to the power of 1, half to the power of 2, half to the power of 3. And so that number is decreasing. and going towards 0. 0.5 to the power 0 is still 1. And so we'll still go through 0, 1, but we'll be decreasing as x increases. So we'll be getting closer and closer and closer to 0. To the left of the y-axis, where you have 0.5 to the minus 1, 0.5 to the minus 2, 0.5 to the minus 3. So if we look at 0.5 to the minus 2, for example, 0.5 is 1/2. So 1/2 to the minus 2. The minus sign flips the fraction upside down. So it's 2 over 1 squared, and that's 4. And so the curve is increasing to the left of the y-axis. So this would be y is equal to 0.5 to the x. And in fact, this is a reflection in the y-axis between y is equal to 2 to the x and y is equal to 0.5 to the x. So you can see that these curves are all exponential curves. They all have this one thing in common. They all go through 0, 1. And if you're ever asked to sketch one, if it's a number that is greater than 1, so if you're just asked to sketch y is equal to 8 to the x, for example, y is equal to 8 to the x, this would be my sketch. And that is enough. It shows the behaviour of the curve. I don't need to sketch it in relation to any other curve. Okay, it may look exactly like my y is equal to 2 to the x, but remember it is a sketch and it is just showing how the curve behaves. Okay, so that will do as a sketch for that curve. So it is important to learn the shape of an exponential curve like this.